We want to examine what happens graphically for Newton's method when a function like this has certain initial guesses. So I'll be clear. If you look on the previous page, I had this shape for you, okay? And it said, we had 1, we had 2, and we had 3, right? And this is the idea that we use. We said, well, suppose you guess 3. We found a point. Do you remember what we did with that point with Newton's method? We drew a tangent line, and then what part of the line did we then look at? It was the x-intercept, and that became our new guess, right? And if you do that over and over again, it's clear that you're going to get really close to that spot. So the question is, does our initial guess matter? And actually it does. Your initial guess does matter, and we're going to show you why. So if you look at this piece right here, it says, suppose we have an initial guess of 0. And the idea is with a function, you're trying to determine the x-intercepts. So we know that the x-intercepts are what? If you look at this graph, where does it cross the x-axis? 2 and 6. So when we work through Newton's method, we would like to come up with 2 or 6. However, sometimes you don't actually get that. For example, if we guessed 0, watch what happens. I guess 0. Well, what I do is I then locate the point. I've located that point, right? Then what do I draw? A tangent line. And from that tangent line, which spot do I find? The x-intercept. So that becomes my new guess. Did that draw me closer to 2 or further away from 2? It drew me further away from 2, didn't it? Well, let's see what happens if we do it again. So we plug this in, and we get another point. I draw the tangent line, and then what part of that tangent line do I look for? We're across the x-axis. Did that draw me closer to 2 or further away? In fact, if I do it again, look at what happens. It draws me, what values is it drawing me out towards? Yeah, in fact, if you guess 0, you're never going to come up with 2 or 6. You're going to come up with negative infinity. Well, all right, let's change our guess. Suppose we guess 1. What do you notice happens at 1? The slope is 0. You have a local maximum, right? So if I guess 1, I want to eventually come up with 2 or 6. I draw the tangent line. And I look for what? I look for where it crosses the x-axis. Does it ever cross the x-axis? No. Undefined. In fact, think of Newton's method. It's x minus f of x over f prime of x, right? That's what we use. Well, what is f prime of x in this situation? It's 0. You're dividing by 0, so you get an undefined result. So here you get negative infinity. Here you get undefined. So hopefully 3 would be an okay guess. Let's see what happens if we guess 3. We guess 3, and depending on how your curve is drawn, it looks like we get that shape right there, right? Where we draw the tangent line. I'm going to draw my tangent line to where I come out like that. What spot of my tangent line do I look for? I look for where it crosses the x-axis right here. So I try it again. I plug it in. I draw my tangent line. Is that drawing me closer to 2 or further away from 2? Further away. In fact, it's going to bring us to what? Negative infinity. So you can see if you actually want to come up with the value of 2, you're going to have to actually guess somewhat close to 2 in this situation. You're going to have to guess close to 2. How about 4? What happens if you guess 4? Yeah, you're not going to come up with 2 or 6 either. You're going to get an undefined result. Hopefully we can find one that works. Let's see what happens if we guess 5. We guess 5. I find the point, and I draw a tangent line. Too often when people do this, they say, oh, it's going out towards negative infinity. No, do it multiple times and see what happens. I'm looking for where it crosses the x-axis. It crosses right here. What do I then do at that point? I plug it in and find a spot on the graph, and I draw another tangent line. Does that bring me back closer to 6? Yeah, in fact, if you then take this point in, like this is going to bring you to 6. This will bring you to a value of 6. You'll eventually find that solution. So if you see this graphical piece, what you want to do is simply just plug in the guess, draw the line tangent, and see where you come out, okay? So for our last piece for this unit, we are going to use Newton's method to find all roots of the polynomial to 4 decimal places. Make sure you have your calculator, okay? Can everybody agree that you cannot just look at this and know what the solutions are? Do you know what a general shape of this graph is? What's the general shape? Something like that, right? Okay, and so I'm going to set up Newton's method. I have x minus the function, right? So that'll be x cubed minus 3x plus 1/2 divided by, what goes on the bottom? What's the derivative? Okay, so what I'm going to do is I'm going to consider the derivative here for a second because I want to come up with decent guesses, okay? Would everybody agree I don't want to guess at the bottom and I don't want to guess at the top, that those would not be helpful? I can figure out a little bit of where the top and bottom are. The derivative f prime of x is equal to 3x squared minus 3. Or 3 times x squared minus 1, or 3 times x minus 1 times x plus 1. So it looks like the derivative is equal to 0 at positive 1 and at negative 1. Everybody agree? So I do not want to guess at negative 1 or positive 1. I want to guess to the sides of those, okay? And hopefully we can find all 3 solutions to this polynomial. Go to your calculator. Go into y equals and type in x minus. We're going to put parentheses in the top because we have x raised to the 3rd. We have minus 3x. We have plus 0.5. Divided by, in the denominator, we have 3x squared minus 3. That's Newton's method. I go to my table. I want to guess to the left of negative 1. Anybody got a number to the left of negative 1 they want to try? So we try negative 2, and we get negative 1.83. What do I then try? Negative 1.833, and I get negative 1.81. So I try negative 1.81, and I get negative 1.81. It looks like that's one of the first solutions. I want to guess something to the right of negative 1, but to the left of 1. Let's guess 0. We'll start again. 0, I get 1/6. I guess 0.166, and I get 0.16825. 0.16825. Looks like I got 0.16825. Now I need to guess something to the right of 1. What would you like to guess? So I go back up here, and I guess 2, 1.722. I get 1.6474. I get 1.6418. And it looks like 1.6418. So what that taught me is that this graph, I know a few things. Negative 1, negative 2, positive 1, positive 2. I know that it crosses the x-axis at negative 1.81, at 0.6 or 16, and 1.64. I know it has a local max at -1. And I know it has a local min at +1. And so it can give you a really good description of the graph. We could find actually the local max and local min if we wanted to. But that's a nice way of finding zeros. Zeros that are otherwise very, very difficult to find. I'm going to show you one last piece here that will, you don't have to write this down, but hopefully this will now make sense to you. Usually I get a few ahas from this. Look at my graph. Does it look like it does my graph look like it crosses at negative 1.81, 0.16, and 1.6? Then if remember our old way of finding the zero, we would press 2. And what would we do? We'd go to the 0 and we'd go to the left and we'd go to the right. And then what does our calculator ask us to do? Notice how we make these guesses for Newton's method? That's the process that your calculator is in fact using. And for this one, you guys guessed 2. Whoop. Sorry. I didn't press enter again. Sorry about that. Enter, enter, and I'm going to guess 2. Oh. I didn't put the cursor in the right spot, did I? Oh, I don't have a +0.5 there. Sorry. All right.